Welcome to Chapter 2, where we dive into numbers and math in Python. We will start with integers, which are whole numbers without a decimal point. On line 1, we create a variable named apples and assign it the value of 5 plus 3. We then print the result to see the sum. A common mistake here is wrapping the numbers in quotes, which turns them into text instead of doing math. Now let us look at subtraction, which works exactly as you would expect. We assign the result of 10 minus 4 to a variable called remaining apples. When we print this out, Python calculates the exact difference. Beginners sometimes worry that Python cannot handle negative numbers, but subtracting a larger number from a smaller one works perfectly fine. You can easily calculate things like debts or temperature drops without any extra code. Multiplication in Python uses the asterisk symbol instead of an X. Here, we calculate the total by multiplying 4 apples by 3 baskets. The print statement displays the final product on the screen. A frequent error is using a lowercase x for multiplication, which Python will confuse for a variable name and cause a crash. Always remember to use the asterisk to keep your math calculations running smoothly. Division in Python is special because it always returns a decimal number, which we call a float. We divide 10 apples equally among 4 people using the / symbol. Notice how the printed result is 2.5, including the decimal. Many new programmers get confused and expect division to return a whole number when the math divides evenly. However, a single slash guarantees a float result every single time. What if you only want the whole number from a division operation without the decimal part? Python provides the double / for integer division, which drops any remainder. We divide 10 by 4 using this operator, and the result is just 2. It is very easy to confuse this with rounding, but integer division strictly cuts off the decimal entirely. Use this when you are counting whole items that cannot be split. Sometimes you need to calculate powers, like squaring or cubing a specific number. Python has a built-in function called pow to handle this easily. We call pow with 2 arguments, calculating 5 to the power of 3, and print the result. A common mistake is trying to use the caret symbol for exponents, which actually performs a different bitwise operation. Using the pow function makes your mathematical intentions perfectly clear to anyone reading the code. Python follows standard mathematical rules for the order of operations, just like you learned in school. In our code, we add 2 and 3, then multiply by 4. Notice how we use parentheses to force the addition to happen first. Without parentheses, Python would perform the multiplication before the addition, giving a completely different answer. Always use parentheses when you want to control exactly how the equation is evaluated. A float is any number with a decimal point, and Python handles them effortlessly. We add 0.1 and 0.1, printing the expected decimal result. However, floating point math can sometimes result in extra decimal places due to how computers represent fractions internally. A huge beginner trap is expecting float math to always be perfectly precise down to the last decimal. You will often see a tiny fraction left over at the very end. The modulo operator is represented by the %sign and is incredibly useful in programming. Instead of giving you the result of a division, modulo gives you only the remainder. We divide 10 by 3 using the modulo operator, which returns a remainder of 1. People often mistake the % for a percentage calculator, which leads to completely wrong outputs. Remember that modulo is strictly about finding what is left over after dividing. One of the most common uses for the modulo operator is figuring out if a number is even or odd. When you use modulo 2 on any even number, the remainder is always exactly 0. Here, we test the number 14 and print the remainder to confirm it is even. A frequent mistake is testing against the number 1 instead of 2. Just remember that even numbers always divide cleanly by 2 with no remainder.
You can safely mix integers and floats in your calculations without causing any errors. We add an integer of 3 to a float of 2.0 and print the final result. Python automatically upgrades the final answer to a float to ensure no decimal data is lost during the calculation. Many beginners try to manually convert numbers before combining them, which is entirely unnecessary. Python handles this background conversion automatically to keep your math safe. When you are working with very large numbers, keeping track of all the zeros can be difficult. Python lets you use underscores to group digits together for better readability. We create a variable with 1 million using underscores where commas would normally go in regular writing. A common typo is placing an underscore at the very beginning or end of the number, which will cause an error. Python ignores the internal underscores when it prints the value.